You live here, Earth, that pretty blue marble floating serenely in space, looking so peaceful from orbit. Yeah, well, buckle up, because your cozy little planet is actually a violent ball of metal and rock, constantly trying to murder everything on its surface. And guess what? That includes you. Now, let's face it. The truth. The dark, horrifying truth. Earth's daily attempts to murder you. Let's start with weather. Nature's mood swings. Hurricanes are just the planet screaming, "I'm having a bad day," only with 200 mph winds and airborne lawn furniture. Tornadoes? Localized tantrums that shred entire neighborhoods into atmospheric confetti. And on average, weather-related disasters, hurricanes, tornadoes, floods, and yes, wildfires, strike every single day. That's about 115 deaths per day, or roughly 42,000 a year, just from weather being weather. But Earth doesn't need theatrics to kill you. It can just crank up the thermostat and slow roast you, or drop it and let you freeze. Simple, efficient, deadly. The 2010 Russian heat wave alone killed up to 56,000 people. Forecast. Unhinged. Volcanoes, pressure release systems. Not just scenic peaks, they're pressure cookers in disguise. When they blow, it's with the force of nuclear bombs. Poison gas, molten rock, and ash clouds tall enough to ground planes and smother cities. All part of the package. In 79 AD, Mount Vesuvius buried Pompeii under ash and pumice, freezing the city mid-breath. People were preserved in chilling detail, caught fleeing, praying, or simply going about their day. One moment, a normal day. The next, volcanic freeze frame. Some eruptions are so catastrophic, they literally rewrite the map. Coming up, the top 10 deadliest volcanic eruptions in recorded history, ranked by body count. From ancient cities remembered in ruins to modern towns swallowed live on camera, these are the moments when a regular Tuesday became geological history. And then there's Yellowstone. Yeah, not just a park with geysers and bison. It's an active supervolcano currently on snooze mode. Last major eruption, 640,000 years ago. Still ticking. Still breathing. Earthquakes, when the Earth decides to stretch. Remember those tectonic plates? They're constantly shifting, but sometimes they get stuck. Pressure builds for decades, centuries. The rock bends and warps until it can't take anymore. Then, crack, it all lets go at once. What happens next isn't pretty. The ground betrays you. Buildings crumble. Highways rip in half. Entire neighborhoods slide into the sea, all in the time it takes to blink. The Richter scale measures this chaos, and the math is terrifying. Each number up means 32 times more energy. So when you hear magnitude 8.0, don't think that's just 2 points higher than 6.0. Think 1,000 times more destructive. It's the difference between a hand grenade and a nuclear bomb. Ugh. The deadliest in history? China, 1556. The Shanxi earthquake killed an estimated 830,000 people when their cave homes collapsed like sandcastles. Yes, people actually lived in cave dwellings there. Some still do today. Fast forward to 2004. A rupture beneath the Indian Ocean triggered tsunamis that raced across 14 countries at jetliner speeds. Over 227,000 lives were lost on what began as a perfect beach day. In 2023, Turkey and Syria lost 55,000 souls to a 7.8 quake that lasted less than 2 minutes. Seismologists study it all, mapping fault lines, measuring tremors, calculating odds. But here's the uncomfortable truth. They still can't tell you when. Only where it's likely, and how bad it might be. Coming up, the top 10 deadliest earthquakes in recorded history, moments when the planet became humanity's cruelest landlord. And those are just the quakes we know about. The Earth has been cracking, shifting, and resetting itself for billions of years, long before we kept records, built cities, thought we were in control, or even existed. Because no matter how advanced we become, we're still just guests, living on borrowed ground. Orbital movements, Earth's drunken stumble. Even with the moon's help, Earth doesn't spin neatly. It stumbles, slowly, awkwardly, and on cosmic timescales. These movements, called Milankovitch cycles, mess with our climate in 3 major ways. Eccentricity is how oval our orbit gets. Every approximately 100,000 years, Earth's path stretches from nearly circular to egg-shaped and back. When the orbit is more oval, the distance from the sun changes more throughout the year. If northern hemisphere summer happens when Earth is farthest from the sun, that summer will be cooler. Obliquity is the angle of Earth's axial tilt. Right now, we're tilted at 23.5 degrees, but over 40,000 years, this varies between 22.1 degrees and 24.5 degrees. A higher tilt means more extreme seasons, hotter summers, colder winters. A smaller tilt means milder seasons but colder overall temperatures. Precession is Earth wobbling like a top that's about to fall. Over 26,000 years, the axis traces a slow circle in the sky, shifting the timing of seasons. On their own, these changes seem subtle. But together, they rhythmically reshape how sunlight hits the planet, especially near the poles. And that changes everything. Roughly every 100,000 years, when the cycles line up just right, high-latitude summers grow too weak to melt all the winter snow. Ice builds, reflects more sunlight, cools the planet further. A feedback loop begins. Rinse and repeat until you're not packing for beach season anymore. You're watching glaciers bulldoze forests, cities, and entire ecosystems. Ow! The last glacial period ended just 11,000 years ago. Back then, glaciers covered 25% of Earth's land. Sea levels were over 400 feet lower. You could walk from Siberia to Alaska, no passport required. Woolly mammoths and saber-toothed cats roamed the land. Our entire civilization, from farming to YouTube, rose during this brief, rare, and stable warm interglacial period called the Holocene. Here's the unsettling part. We're still in the Quaternary Ice Age, which began 2.6 million years ago. We're just living through one of its rare intermissions. The movements haven't stopped. They're still ticking, still shifting, still perfectly capable of flipping the climate again. Earth is just waiting for the right moment to plunge us back into the next glacial period and hit the reset button on our entire civilization. Magnetic field reversals, when Earth leaves the back door unlocked. Earth's magnetic poles do flip. North becomes south, and south becomes north. On average, these full reversals occur every 450,000 years or so, but they don't follow a schedule. The timing is irregular and unpredictable.
Oh no!
During a reversal, Earth's magnetic shield doesn't disappear, but it does weaken. A lot. At the peak of the transition, it could lose up to 90% of its strength, letting far more cosmic radiation slip through the cracks. That means disrupted power grids, failing communication satellites, scrambled navigation systems, and a whole lot more radiation hitting everything from migrating birds to airline passengers. The entire shift can take thousands of years, but the most dramatic polarity changes might happen much faster, possibly within a single human lifetime. It won't kill you outright, but it does leave the door wide open, and the universe doesn't knock. The last big flip, about 780,000 years ago. The biological nightmare. And just in case the weather and geology weren't enough, Earth also swarms with things that want to eat you, infect you, or ruin your day for fun. From microscopic viruses that hijack your lungs, to apex predators with rows of razor-sharp teeth designed to make you a snack, nature is casually horrifying. Even the seemingly innocent life forms, plants and fungi, are in on it. Poison ivy. Deadly nightshade. Neurotoxic mushrooms. They just sit there in forests and fields quietly, looking harmless while plotting to end you. The universe joins the kill humans party. As if living on a geologically unstable rock wasn't bad enough, the cosmos has RSVP'd to the extinction party, and it brought snacks. Solar storms, the sun's temper tantrums. Sometimes, the sun just loses it, flinging bursts of energy and charged particles across space. A powerful solar storm, particularly a massive coronal mass ejection, CME, aimed directly at Earth, could trigger a geomagnetic superstorm. This wouldn't vaporize you instantly, but it could deliver a devastating punch to the very infrastructure that sustains modern human life. We're talking widespread, long-lasting power grid failures. GPS and communication satellites knocked offline. Radio silence across the globe. Your phone won't spontaneously combust, but the world it connects to could plunge into darkness and silence. No power, no internet, no logistics. Suddenly, providing food, clean water, sanitation, and medical care for billions becomes nearly impossible. It's not the end of humanity. It's something worse. The sudden collapse of everything humanity has built. You'd go from ordering takeout on your smartphone to figuring out how to make fire with sticks. From global connectivity to wondering if your neighbors are still alive. The sun doesn't need to kill you directly. It just needs to unplug your civilization. Asteroids and comets. Cosmic baseball. The universe has a favorite sport, high-speed baseball, with chunks of rock flying at an average speed of 17.8 kilometers per second. And guess what? We're standing on home plate. The dinosaurs could tell you how that turned out. Oh wait, they can't. They're oil now. Let's talk numbers. The asteroid that wiped them out was about 9 kilometers wide, slamming into Earth at over 25 kilometers per second. It triggered a magnitude 9 to 11 earthquake, blasted 25 trillion metric tons of material into the atmosphere, and wiped out 75% of all life, including every non-avian dinosaur. But here's the unsettling part. We get hit way more often than you think. In 1908, a 50 to 60 meter wide rock exploded over Siberia. The Tunguska event flattened 8 million trees across 2,150 square kilometers. And that wasn't even a direct impact. It exploded in the air. Asteroids that size hit us every few hundred years. Smaller ones? A 20-meter asteroid explodes in our atmosphere about once every 60 years. And then there are comets, the wild cards. These ice balls from the outer solar system can arrive at even higher speeds, sometimes exceeding 67 kilometers per second. Their chaotic orbits make them harder to spot and track, often appearing with little warning. And they can break apart unpredictably, turning a single threat into many. The good news? We're getting better at spotting the big ones. The bad news? There are still plenty we haven't found. And a city killer can reach Earth at up to 20 kilometers per second. At that speed, you don't get much warning. Barely enough time to update your will. The cosmos doesn't have to plan our destruction. We're just in the way, like an anthill beneath a passing group. Gamma-ray bursts, a quadruple threat to life on Earth. A supernova within 6,000 light-years could unleash gamma rays that would strike, fry, freeze, and dissolve life on Earth all at once. Here's how the destruction unfolds. The initial strike. The gamma-ray burst hits first. Radiation so intense it sterilizes microbes in the stratosphere, the second layer of Earth's atmosphere. You say, who cares about those? The same rays fry the electronics that modern life depends on. Satellites die. GPS fails. Communications collapse. Feel better now? Then, ozone depletion. Gamma rays slam into the atmosphere, breaking apart nitrogen and oxygen molecules. This creates nitrogen oxides that shred the ozone layer. Without that protective shield, UV radiation pours in. Sunburns are now the least of your worries. DNA damage, mass skin cancers, cataracts, immune system collapse. Marine plankton, the base of the ocean food chain, die massively. Coral reefs bleach. Crops wither under unfiltered sunlight. Global agriculture collapses. You keep hoping this will end, praying for relief, but it's only the beginning. Then, global dimming. Those same nitrogen oxides trigger photochemical smog, cloaking Earth in a sun-blocking haze. For months, maybe years, survivors face a nightmarish transition, dodging lethal UV during the day while temperatures drop slowly, then catastrophically. Photosynthesis falters. Crops that endured the UV now fail in the cold and darkness. What began as a radiation crisis becomes a famine, then a deep freeze. A world where food can no longer grow. Finally, acid rain apocalypse. That smog eventually rains down as acid. Lakes and rivers turn toxic. Fish die. Amphibians dissolve. Forests rot from the roots up. Even cities decay. Stone, metal, and concrete, crumbling under the chemical assault. In the end, it's acid that finishes the job. One flash in the cosmos, and Earth becomes our tombstone. And we are not even the target. The human element, we're the worst house guests ever. Here's the truly absurd part. For all the cosmic threats and geological chaos, one of the biggest dangers to life on Earth is us. We're like the worst house guests imaginable. crashing on the couch of a bad-tempered host. And instead of being quiet and grateful, we're actively trashing the place. We're basically saying, hey, what if we pumped a bunch of heat into your atmosphere? Also, we're gonna borrow some of that ozone layer. Promise we'll give it back. But here's the thing. If we mess up badly enough, Earth won't die. It'll just sneeze us off like dust on a coffee table and keep spinning for another few billion years. Maybe the next dominant species will be hyper-intelligent dolphins or psychic cockroaches. Either way, Earth won't miss us. Think about what this planet has already survived. Asteroid impacts that triggered global tsunamis and earthquakes. Mass extinctions that wiped out 90% of all life. Deep freezes that turned Earth into a snowball. Volcanic eruptions that blanketed continents in molten rock. And yet, here you are, existing, breathing, scrolling. Every single day you wake up is a statistical miracle, an improbable fluke. And your biggest problem? Whether your Wi-Fi can stream in 4K. But why is Earth the most dangerous place in the universe for human beings? Because it's the only place humans exist. For now. So enjoy your brief stay on this beautiful but unstable rock hurtling through space. And maybe, just maybe, don't completely trash the place. You're stuck with it. But Earth? It can kick you out anytime, like it did to 99.9% of its previous guests.